Okay, so I look at the first one. We're looking at the absolute value of x is equal to 8. So this is just kind of an introduction. Make sure we remember how you're supposed to do these. So if I take the absolute value of x, I should get 8. So what is it that x has to be? Okay, absolutely. You like that? Absolutely, because it's absolute. Okay. So when we take absolute value functions, this is the steps we're going to take. We have to make sure the absolute value bars are isolated, which means they're the only thing on their side of the equal sign. They are. Once we have that, then there are two possible cases. What is underneath or inside of the absolute value bars must be positive 8, or what's underneath has to be negative 8. So what we do is we take what's inside, set it equal to plus or minus what's on the outside. Okay, so it's always two cases. So you'll normally see, this was an easy one. You'll normally see me set it up like this, case 1 and case 2. And then we'll say what's inside equals the positive of the outside, and what's inside equals the negative of the outside. Okay, now we look at the second one. So this one is a little bit more complicated, not much. We have the absolute value of x plus 8 equals negative 3. So first thing, I need to get my absolute value bars isolated. They are. They're the only thing on their side of the equal sign. So my first case is what is inside the absolute value bars, x plus 8, should equal negative 3. The second case, what's inside the absolute value bars, x plus 8, would equal negative 3. Okay, well, we write negative 3 as positive 3. Now solve each equation. So on the left, x plus 8 equals negative 3. I move the 8 over, it becomes negative. So negative 3 minus 8 is negative 11. And then on the right, we move the 8 over, it becomes negative 3 minus 8 is negative 5. Now something that's very important with absolute value equations is just because you've solved it doesn't mean it's correct. You have to plug them back in to make sure it makes the equation true. So let's look at this first one. If I plug in an 8, the absolute value of 8 is 8. So that works. If I plug in negative 8, the absolute value of negative 8 is 8. So that one works. Looking here, plug in negative 11. Negative 11 plus 8 is negative 3. The absolute value of negative 3 is 3, not negative 3. Okay? If I look at this problem at the beginning, what is it telling me? It's telling me if I take the absolute value of something, it has to equal something negative. That can never happen. Okay, so this one here, even though we solved it and got negative 11 and negative 5 as my solutions, neither one works when I plug them back in. So the answer here would be no solution, or what's called the empty set. Looking at the first one, we have the absolute value of x minus 5 equals 4. So I need the absolute value bars isolated. Well, they already are. They're the only thing on their side of the equal sign. So I set it up as two cases. Case 1, we have what's underneath or inside the absolute value bars is equal to positive 4. And in case 2, what's inside the absolute value bars is equal to negative 4. Solve those by adding 5. So that tells me x is 9 and x is 1. Now here's one that's a little more interesting. We've got 2 absolute value of x plus 8 minus 6 equals 0. So this is the first problem we've had where the absolute value bars are not isolated. They are not the only thing on their side of the equal sign. So that's the first thing we have to do. Get the absolute value bar isolated. So we move the negative 6 over and it becomes positive. So I've got 2 absolute value of x plus 8 equals positive 6. And now the absolute values are being multiplied by 2 on the outside of them. So we're going to divide everything by 2. So that tells me the absolute value of x plus 8 is equal to 3. Now I have my absolute value bars isolated. So I can set up my cases. Case 1 and case 2. What is inside the absolute value bars is equal to positive the outside, and what's inside is equal to negative the outside, which is 3. I'm going to subtract 8 from both of these, so x equals negative 5 and x equals negative 11. Okay, let's plug all these back in just to make sure. If I plug in a 9, 9 minus 5 is 4. The absolute value of 4 is 4. I plug in a 1. 1 minus 5 is negative 4. The absolute value of negative 4 is 4. So both of those work. Here, plug in negative 5. Negative 5 plus 8 is 3. The absolute value of 3 is 3. 2 times 3 is 6. 6 minus 6, 0. Works. Plug in negative 11. Negative 11 plus 8, negative 3. Absolute value of negative 3 is 3. 2 times 3 is 6. 6 minus 6, 0. Okay, it tells here an equation that involves 2 or more variables is called a formula. Solve the following formulas for the specified value. S equals P plus PRT for P. So it's telling me I want to get P isolated. Get P by itself. Okay, what's the problem with that here? Huh? So there's a P in the RT? So how could we get rid of the RT? So if I divide it by RT, don't write this down. I'd have to divide everything by RT. And so now I'd have S over RT equals P over RT plus P. Now what? Now there's an RT with this P. That didn't help a lot. I moved the RT from one P to the other P. Right? So this is one of those problems. What's my goal? My goal is to get P by itself. Well, what's the problem with that? Well, there are two different P's. There's a P here and a P here. If I could rewrite this with just a single P, that would be ideal. Does anyone know how we could rewrite this addition with just a single P? Yeah, so we could factor a P out. I didn't. That was all lowercase. Okay, so if I pull the P out, that leaves me with 1 plus RT. Factoring is a great way to rewrite a single variable or two variables as a single variable, right, if they're the same variable. Now if I want to get P by itself, much simpler. P is being multiplied by 1 plus RT, so I'm going to divide by 1 plus RT on both sides. So that tells me, I'm flipping my equation, P equals S over 1 plus RT. So now we're going to solve A equals 1/2 h times B1 plus 1/2 h times B2. Does anyone know what this is the formula for? So you just have a formula for triangle and square? I mean, what are you doing with a triangle and a square? Circle! Hexagon! That's how you make a hexagon, that formula.
I thought it was a triangle one.
What do you mean it's a triangle? What do you mean triangle one?
I thought it was a triangle formula because
But what kind of formula? They just... Oh, the area of a triangle. Oh. No, the triangle formula. You plug this in and it makes a triangle. I mean... It doesn't. No, it doesn't. It doesn't. Okay, so this is not the area of a triangle.
See, it was wrong either way.
Area of what?
Hexagon.
Okay, so it could probably work for the area of a square, but that's not the reason we... Yes, area of a trapezoid is what that's the formula for, because trapezoids have two bases that are different sizes. So B sub 1 is the base, one base, B sub 2 is the other base. So we're wanting to find the height, isolate the height of the trapezoid. Any ideas? How could we do that? Okay, I could factor out an h. You could even factor out a 1/2 h if you wanted to. So let's look at what would happen either way you did it, okay? And then you can make a decision which one you like better. So if I just factor out an h, which is normally the way I would go, because I'm trying to get the h by itself, it leaves me with 1/2 base 1 plus 1/2 base 2. Now I want to get h by itself, so I'm going to divide by 1/2 base 1 plus 1/2 base 2 on both sides. So that tells me the height is equal to the area divided by 1/2 of base 1 plus 1/2 of base 2. And that's fine, but that's a little awkward because there's a big fraction, and then in the denominator there's other fractions, so you've got fractions in fractions, which is not the best looking thing. Yes. Now, if you would have factored out a 1/2 base, or 1/2 height, look what happens there. I factor out a 1/2 times the height. That leaves me with base 1 plus base 2. Now, I would divide by base 1 plus base 2 on both sides. So it tells me the area over base 1 plus base 2 equals 1/2 the height. Now, how can I get rid of multiplying by 1/2? I can multiply by 2. And so that would tell me the height is equal to twice the area over base 1 plus base 2. So that one looks a little neater, right? But they both are equally correct. Next, C equals 5/9 times F minus 32. We're going to isolate for F. So you know what this is the formula for? Fahrenheit to Celsius, Celsius to Fahrenheit, absolutely. So we want to get F by itself. Why is the F not by itself? Well, we've got subtracting 32, we got 5/9. Which one of those things do I want to get rid of first? 5/9, I agree, because it's farther away from the variable F. So we get rid of multiplying by 5/9 by multiplying by 9/5, the reciprocal. So that leaves me with 9/5 times C equals, so 9/5 times 5/9 is gone, and I'm left with F minus 32. Now how can I get rid of subtracting 32? We'll move it over, make it positive. 9/5 C plus 32 is equal to Fahrenheit. So what's it going to look like if I get Y by itself? if you take a standard form of an linear equation and I get y by itself,
Why? Just kidding, that doesn't have a B.
but that's what it is.
Doesn't have a B.
That's what it is. If I isolate for y, it's going to be in slope-intercept form. Y equals mx, so something times x plus a constant. Okay, now we're going to have different variables this time because we're not starting with that nice y equals mx plus b form, but that's what we're getting it into. So we're moving this from standard form to slope-intercept form. So I want to get y by itself, so I'm going to get rid of the ax first. So that tells me by equals negative ax plus c. That's being multiplied by b, so I'm going to divide everything by b. So that tells me y equals negative ax plus c all over b. And that would be a fine final answer. But if you wanted to make it look a little bit more like slope-intercept form, you could break that fraction apart over its denominator. So negative a over b times x plus c over b, where this is the slope and c over b is the y-intercept. Okay, here we've got s sub n equals a sub 1 minus a sub 1 times r to the n over 1 minus r. And I want to isolate for a sub 1. So I'm going to get rid of this fraction first. So since it's all being divided by 1 minus r, I'm going to multiply both sides by 1 minus r. So that's going to be s sub n times 1 minus r equals a sub 1 minus a sub 1 times r to the n. Now I want to get a sub 1 by itself. Well, there are two of them on the same side, so I can factor. That leaves me with a sub 1 times 1 minus r to the n is equal to s sub n times 1 minus r. Now divide both sides by 1 minus r to the n. And I'm finished. A sub 1 equals s sub n times 1 minus r over 1 minus r to the n. We want to write a formula that expresses the width of a rectangle as a function of its area and its length. Which kind of got me sidetracked here. So this word, you know, what's that word? Huh? Yes, everybody can clearly see that word is, huh?
Alright.
Height.
Write your eyes funny.
Thanks. It's really hard on this iPad. If you'd like to try it, you could. Don't touch it. COVID. So this is height, not height. Height is not a word. Okay, so what's your height? I don't know. Doesn't exist. Okay. No, it's not a word. There is no word height.
Then how do you say it?
Height.
Hot. What's your hot?
Height. Yeah.
Say what your hot. What's your hot?
Nope. Wrong. How tall are you?
It has a T. I'm pretty sure I've used that like in an essay.
There's a T on it, so it's hot. Is that what you said? There's no H at the end.
I don't know.
So like B-I-T, bit. Is that biff? Yeah. No.
I lisped when I was little.
It ends in a T, so it's at the end. No. TH. Okay. Write a formula that expresses the width of a rectangle as a function of its area and length. So what is the formula that has width, area, and length in it for a rectangle? area of a rectangle
Good job, man.
is equal to
2W plus 2 times L.
I love the area of a rectangle.
that
It's
would
just
be the
length times width.
perimeter,
I'm like, it's just length times width.
right? Perimeter where you add up the four sides, width, plus length, that'd be 2 widths plus 2 lengths. So you're doing perimeter. Area is
Length times width, I don't know.
length times width. Length times width. And I want to isolate it for width. It tells me write a formula that expresses the width as a function of area and length. So get width, get the W by itself. It's being multiplied by L, so I'm going to divide by L. So that tells me the width is equal to the area divided by the length. If x and y are real numbers, then the ordered pair x comma y is called an ordered pair of real numbers. So, everybody familiar with graphing? Do I need to do an in-depth study? So remember, left to right is the x-axis, up and down is the y-axis. Where the two axes meet, that is the origin. Right? 0, 0, ordered pair. And then any point on the graph, we can represent it by an ordered pair using parentheses, x comma y, close parentheses. So what I'm amazed, I see a lot of people write ordered pairs without parentheses. And I don't, maybe none of y'all do, but it's crazy how often I see that. So here's an example. First thing, we want to identify quadrants. In which quadrant, if any, are the points -2, 6, 0, -1, 5, 3, and -4, -4 located? So does everybody remember how we name the quadrants? So the first quadrant is A? No, it's called the first quadrant. Which one of those four is the first quadrant?
It's the top left. Or is it the top right?
I thought it was the top
I don't remember.
Top right is the first quadrant.
Well, that's weird.
This is the second, this is the third, and this is the fourth.
See, that's wrong.
Well, just wait. After Christmas, when we get to trig, you'll be doing this a lot, and you'll understand why they're named this way.
Anything counterclockwise is just,
Maybe it's.
That's a positive direction of rotation.
I don't like it.
I'm just telling you, get used to it. We're fixing to do, after Christmas, we'll do a lot of that. So,
A clockwise like
yeah, that'd be clockwise. So this one rotates counterclockwise.
that. Is it because like the first one is because they're both positive and that one?
Yes, that's the first quadrant because the x's and the y's are positive there.
Okay, and then the fourth one is because all of them are negative.
That's the third where they're all negative.
Then that just makes no sense.
But if you rotated your way, it would still be the third.
Huh?
You want to rotate the other way?
Well, no, I was just saying I thought that like the first one was the first one because they were all positive, so I figured
It
the
is.
fourth one would be the ones where they were all negative.
Yeah. No.
That would just
So if you named them, you would name this the first, this the second, this the third, and this the fourth?
Yeah. Yep. Or I would just swap them too.
1, 2, 3, 4?
Yep. Or I would just swap the negative, like all the negatives on the other side.
So you want these to represent positive numbers now, but then when down here you want it to be negative?
Yep.
That'd be real easy for everybody to follow.
I think it would too.
But that would make no sense.
No, it doesn't. Thank you. It didn't make a lick of sense. It doesn't. I agree. So here we go. The first point is -2, 6. We want to identify what quadrant are we in. So from the origin, -2 goes to the left, +6 goes up. That puts us in the second quadrant. So -2, 6 is in the second quadrant. Next, 0, -1. So I start at the origin here. Go nowhere. -1 means I go down 1 to there. Okay, what quadrant is that in? It's in neither quadrant. It's in between the third and the fourth, but it's on the y-axis. So we would say 0, -1 is on the y-axis. That's how we define it. It's not in a quadrant, it's on an axis. Next one is 5 and 3. So starting at the origin, go right 5, go up 3. That puts us here. What quadrant is that in? The first quadrant. And then -4, -4. I'm going left 4 and down 4, which puts me in the fourth quadrant. So -4, -4. I'm sorry, it's in the third quadrant. She's getting me all messed up now with my quadrants.
See, it makes sense.
It did not make a lick of sense. Any questions there?
Or else you would have said it.
Okay, now we're going to work on plotting points. So it tells me to plot the following points on the XY plane. So first is the point 3, 5. So I start at the origin. 3 means you go right 3. 5 means you go up 5. There is my point 3, 5. So you may want to label it so you can know which point is which. Next point is at 4, -5. 4 means I go right 4. -5 means I go down 5. And that puts me right here. So this is the point 4, -5. And that doesn't show it. Well, it shows it better on the projector than it does my screen. It's crazy. Okay. Next, we've got -3, 4. That means I'm going to start the origin, go left 3, go up 4. And there's my point, -3, 4. -2, -5. I'm going left 2, down 5. Puts me there. And then 0, 2. 0 means you go nowhere. 2 means up 2. So there's my point, 0, 2.